Right, now we are going to start a new topic here, air pollution. And it is quite related to what we were just talking about, with respect to climate change. Now, air pollution comes from a variety of sources. Some of them are anthropogenic, some of them are actually natural. Air pollution, by definition, indicates presence of certain compounds in the atmosphere uh, in concentrations that are greater or great enough to create harm, to result harm, damage to organisms, ecosystems, or to any natural element, or to humans and to man-made structures, right? Or alter the climate scenario. So now, what are the natural forms of pollution that I was referring to earlier on? Well, when wind blows across dry land, that picks up dust, and that dust could land elsewhere, could get into the atmosphere. That's one way. Okay? Um, when forest fires happens, when volcanic eruptions occurs, right? Many sulfides, carbon monoxide, carbon dioxide, partially burnt, low weight carbon compounds, uh, acid containing compounds, or acidic gases, mists could be emitted to the atmosphere. And certain plants naturally, as kind of a anti-herbivore defense, release volatile organic compounds. Now, those are also known to be harmful to the environment. And in wetlands, the microbial communities, metabolize organic compounds in different pathways, and that could release oxides of nitrogen, oxides of sulfur, hydrogen sulfides, methane, right? The same, and the methane production also happens in termite gut, ruminant gut. But all the forms of natural air pollution, although it happens in a wide variety of ways all over the world, it is fairly limited, it's minimal, and there are natural biogeochemical cycles, processes that will kind of remediate the ill effect. But anthropogenic, human-made, man-made air pollution, which includes releasing air pollutants from fossil fuel burning in power plants or in industrial facilities, or from automobiles to the atmosphere. Now, that anthropogenic aspect is much greater, and also the most devastating. And the emissions produced by humans are so high, the natural processes cannot take care of it. Scale of impacts of air pollution is global, meaning pollutants released from developing countries or industrial countries can land completely somewhere else and create ill effects. So pollutants can be carried over atmospheric circulation through wind patterns. So that's why addressing air pollution is in fact a global, should be a global effect as well as a local national effect. There are two forms of air pollutants that I wanted you guys to know. Um, Primary pollutants. Those are the pollutants or gases emitted by either natural or anthropogenic processes. Those includes carbon monoxide, carbon dioxide, and carbon monoxide comes from partial combustion of organic matter, carbon containing matter, right? And sulfur dioxide, a wide variety of types of oxides of nitrogen, methane, and many other gases that are released when you burn hydrocarbons. Now, what happens is some of these primary pollutants can interact with each other, right, or react with each other, or these primary pollutants can react with other harmless natural constituents of the atmosphere, like oxygen, water vapor, right, and creates new forms of pollutants, and we call those new form of pollutants secondary pollutants, right? and those secondary pollutants could actually have more devastating effects. If you recall, in my last end at the last bit of my climate lecture, I talked about industrial smogs. Now, industrial smogs are actually a result of secondary pollution. Speaking of air pollution, particularly speaking of secondary pollutants and industrial smogs, we cannot not talking about China. And here you're looking at two photographs. The same wave in Beijing, right? In taken in 2009. Um, Within November, on one day on the top photograph, you can see it's a relatively a good day, with good air conditions, breathable air, clear view. On the bottom image, you can see this haze, and as you can see in the photograph itself, on that day, the government or the city of Beijing issues hazardous warnings, meaning that you might have to wear a mask, if you have to go out or stay indoors. So this is kind of a very clear yet alarming photograph to indicate how damaging industrial smoke and air pollution can be. China um, is one of the world's most well-known country that suffers the greatest from industrial smogs. And China has, aside from Beijing, there are about 16 more cities that suffer frequent industrial smogs. There are 20 overall cities that in China that are known to suffer from recurrent industrial smogs, but out of those 20, 16 of them tops in global scale cities that suffers from recurrent industrial smogs that are hazardous to humans. In the year 2010, about 1.2 million people died in China, and those deaths can be the cause of death can be related to some sort of a uh, ill effect that comes from air pollution, chronic or long term, chronic or acute. And air pollution, as of now today, is kind of the fourth leading causes of death in China. And Chinese government and cities suffer a lot because of pollution. Pollution because of pollution, people get sick, and you have to treat sick people in hospitals. So that is a cost. And also, certain gases or the constituents of industrial smog can also damage engineering structures, buildings, bridges, roads, monuments. So repairing those, is a cost. And the cost that it takes for the Chinese government to remediate pollution is also increasing within the last few years. And other than China, certain developed countries like Japan is suffering from air pollution. South Korea, Singapore have cities in Singapore. Well, Singapore only has one major city, Singapore City, suffered extreme level of air pollution. Maybe not to the same extent China does, but they do. And also other countries like India are also and suffering from major events of air pollution. Particularly cities like Mumbai is known to suffer from recurrent events of industrial smogs. And other countries in South and Southeast Asia, for example, um, Bangladesh, Pakistan, um, Afghanistan, are also known to suffer from extreme air pollution. The Clean Air Act of the United States, mandated by Environmental Protection Agency, have recognized six common air pollutants that is vastly found within the U.S. All across the country, and that are also found in other cities, other countries that suffers from air pollution. Those includes presence of ground level ozone, lead, sulfur dioxide, or you can better yet to say that oxides of sulfur, um, nitrogen dioxide, or better yet, variety of oxides of nitrogen and carbon monoxide, and particulate matter. Now, particulate matter is simply partially burnt, lightweight carbon containing compounds that are so light in weight, they actually float around the atmosphere. You can add a seventh one that is probably methane, right? and that 6 to 7 pollutants are quite common, commonly occur in anywhere in the world that suffer from significant degrees of air pollution. So these major pollutants I mentioned in the previous slide are also known as criteria pollutants, and those pollutants have different types of sources. First, look at the particulated material. Again, what are particulated material? Largely those particulated material are organic, meaning containing carbon, meaning they're coming from partial combustion of fossil fuel. And there are other ways where lightweight materials could be airborne. So the greatest source of particulated materials in the atmosphere is transportation, meaning fossil fuel burning in motor vehicles. Lead, again, coming mostly from transportation and smelting and processing. Now, for two different reasons, in smelting and processing plants, where they actually process metal and other minerals, lead could be present as a contaminant, so it should be released. So, as a kind of a waste product, lead could be emitted to the atmosphere. Transportation is a different story. We know that back in the days, um, the oil companies mixed lead with gas to increase the efficiency of fuel combustion. It actually maintains the engine very well. It prevents wear and tear, increases the octane rating, and overall, like I said, presence of lead increased the efficiency of fossil fuel burning. Hence, it was there not as a contaminant but actually as an additive. But now we realize that lead is bad. Now we have unleaded gasoline in the market. Oxides of nitrogen, well, largely coming out of power plants plus transportation. Again, nitrogen oxides are produced during fossil fuel combustion. Now, where does nitrogen come from? Is nitrogen present in fossil fuel? No. Well, what happens is, during the process, you burn fossil fuel, the temperature reached at automobile engines or in industries, power plants are extremely high. It actually combines atmospheric nitrogen with atmospheric oxygen, right? And that is the source of nitrogen oxides from power plants and in automobile industry, or rather, not automobile industry, from automobile. Carbon monoxide largely comes from transportation, again through automobile engines, particularly if the engine is not well maintained, the oxygen supply to the engine reduces, so some of the fossil fuel may not be completely burnt. Hence, instead of carbon dioxide, that releases carbon monoxide. Um, and sulfur dioxide again comes from power plants largely. That is because sulfur could be present as a contaminant, particularly in coal, right? And when you burn it, sulfur burns up and released as carbon dioxide. Another compound that I wanted to mention is volatile organic compounds, quite related to particulate material, um, at least structurally. um, that too comes from a variety of sources, particularly when you are manufacturing certain chemicals. There are certain solvents that are used to dissolve different types of chemicals, into one formula. So this process involved this kind of mixing, generates lots of volatile organic compounds that could be easily airborne. Now what we're going to do is take those criteria pollutant one at a time and talk about it. First, sulfur dioxide. The natural sources of sulfur dioxide includes the sea spray. Now, oceans receive sulfur from direct atmospheric depositions as well as from surface runoff from the land to the river and from the rivers to the ocean. Right. So when the ocean, with the movement of ocean currents, ocean waves, it could actually release containing sulfur um, as a as a spray. And volcanic eruptions also releases sulfur in terms of sulfur dioxides. Now, how does that happen? Well, we know that volcanic eruption releases so much different types of minerals in gaseous forms to the atmosphere, and that's a major natural source that the atmosphere receives sulfur dioxide. And Anthropogenic sources of sulfur primarily includes combustion of fossil fuel, mostly crude oil and coal. In crude oil and coal, you get a lot of sulfur as a contaminant. When you burn it, you release it. And also refining crude oil into diesel, petrol, and a variety of other forms of gasoline also involves kind of teasing apart these contaminants, and and those contaminants, when you tease it apart, when you refine it, are unfortunately released into the atmosphere. The same thing happens in when you're processing natural gases, and also when you're extracting sulfur from sulfide ores or from sulfide deposits in the earth. It also involves releasing sulfur as sulfur oxides, particularly when you melt the sulfur containing compounds. Sulfur dioxide, what is the impact of sulfur dioxide? Well, sulfur dioxide is a very corrosive gas. It has acidic properties. In the atmosphere, sulfur dioxide dissolved in atmospheric water vapor, atmospheric water, and makes sulfuric acid. And sulfuric acid could damage soil. It could reduce soil fertility. You might think, now, sulfur is a nutrient as well. So, for a nutrient poor soil, if you add sulfur as sulfuric acid in low concentration, it will actually boost plant productivity. But in areas that suffer continuous sulfur dioxide pollution, the addition of sulfuric acids to the soil will actually damage plant, reduce plant productivity, reduce plant growth, and also kill plant roots, damage chlorophyll, right? And also bad for the animals, particularly for soil fauna as well as aquatic life forms. The gills are known to be damaged to irrecoverable degree uh, when the acids, when sulfuric acids mixes up in aquatic habitats, particularly in wetlands. And if you breathe sulfur-containing air, particularly like in these industrial smog-like situations, it could create severe breathing problems, which actually may have many complications. Be damaging the lung surface, damaging alveoli, damaging air ducts, damaging alveolar ducts, damaging um, trachea or bronchioli or bronchi. Any part of the respiratory tract can be damaged by presence of sulfur dioxide because it is highly corrosive. Um, and also sulfur particles, when present in a particulate form or in droplet form, um, creates reduced visibility. So when sulfur dioxides or sulfur particles or sulfur droplets are a component of industrial smog, that smog can literally reduce visibility. So it could actually create driving hazards on highways. Okay, now we are moving on to nitrogen oxides. Um, so nitrogen oxides are produced when when there is any particular situation, largely industrial or automobile engines, where the air is heated at 650 degrees or above in the presence of oxygen. In that situation, the atmospheric nitrogen combines with atmospheric oxygen and produces nitrogen oxides. Again, where do you find this much high of temperatures? Um, in automobile engines, as well as in many different kinds of industrial applications that generates heat. That includes fossil fuel burning. Um, and this is exciting. And I just mentioned that combustion of fossil fuel in automobile engines and in power plants is the key situation where the temperature reaches above 650 degrees, which facilitates combination of nitrogen and oxygen into nitrogen oxides. And also, as a natural source, there are certain bacteria that converts nitrogen-containing compounds into nitrous oxides. Now, that's a natural phenomenon. Happens but to a very minimal degree. And some of those nitrogen oxides that we are talking about have kind of a reddish brown color, and those ones could lead to formation of industrial smogs in cities. And all forms of nitrogen oxides are also greenhouse gases, meaning they can trap infrared radiation and contribute to global warming. Um, when nitrogen oxides combine it with water, for example, when atmospheric pollutants of nitrogen oxide combines with water droplets or with water in clouds, it forms nitric acid. And nitric acids, when it actually deposits through dry depositions or through precipitation into water bodies, it could create eutrophication. Meaning what? We talked about eutrophication before more than once, as I can recall. Eutrophication is a situation where the nutrient contents, like nitrates and phosphates, increases dramatically in aquatic habitats, which leads to proliferation of algae and other phytoplankton that can assimilate those excess nutrients and grow rapidly. So, and you also already know the after effects of eutrophication, which we will cover in a different topic. Um, Now, eutrophication encourages eutrophication, or rather addition of nitrates into water, encourages growth of weed and phytoplankton and algae, macroalgae, which could lead to which could actually clog waterways first, and also outcompete native species of plants. And nitric acid, upon contact on human, could create irritable situations. For example, it could actually impair eye if nitric acid containing rainwater, were to happen to make contact with eyes, and if you inhale nitrogen oxide or oxides of nitrogen, it could actually damage your respiratory system, your throat, because again, like sulfur dioxide, nitrogen oxides have acidic properties. That's why it acts like an irritant. And nitrogen oxides also aggravate other respiratory illnesses like asthma and bronchitis. Makes it worse for the patients. And like sulfur dioxide, nitrogen dioxide, when leads to acid precipitation or acid rain, um, could suppress plant growth, plant reproduction, and plant primary productivity. Okay, now to carbon monoxide. Carbon monoxide can be produced by incomplete combustion or incomplete burning of carbon containing material. It could be fossil fuel combustion, it could be incinerating waste material, it could be happening in a motor vehicle, right? If the engines are not well maintained, right? If the oxygen supply to automobile engines is blocked or impaired, then of course it leads to incomplete combustion of fossil fuel, right? And also, when you're during forest fires, this could happen too. If a fire were to happen in a thick dense forest or in a grassland, if oxygen is not supplied properly, to the burning vegetation, then that could also release as carbon dioxide or carbon monoxide. And when for agriculture, when you burn forests, this happens a lot. And so what is the problem with carbon monoxide? Carbon monoxide acts like a toxin to human body, right? So carbon monoxide can bind with hemoglobin permanently, right? We know hemoglobin mostly binds with carbon dioxide and oxygen, and that bond is reversible, right? Depending on the oxygen and carbon dioxide partial pressure, um, carbon dioxide or oxygen bonded to hemoglobin can be released. But when hemoglobin interacts with carbon monoxide, that bond is irreversible, right? So, in that situation, the red blood cells will be unable to carry oxygen to your tissue and carbon dioxide away from your tissue, right? So it could actually kill you if you are exposed to high concentrations of carbon monoxide during a shorter period of time. Within matter of minutes, it could actually kill you, right? But if you are exposed to carbon dioxide in lower concentrations for a prolonged period of time, that could lead to heart attacks and also other forms of aggressive lung diseases. Now, the actual physiology behind this is not very well understood, but studies show that cities or the people who occupy cities that have a high concentration of not high concentration of low concentration of carbon dioxide for a carbon monoxide for a longer period of time tends to suffer from these kind of ailments. And also, carbon monoxide is considered to be a powerful greenhouse gas, right? And I've heard that sometimes, it could be even more powerful than carbon dioxide, so can contribute to global warming as well. Now, to ozone is a pollutant in the low atmosphere. Okay, and we know ozone was a protector in the upper levels of the atmosphere, but in the troposphere, it's actually a pollutant. Now, what produces ozone? Well, ozone is not a primary pollutant; it's a secondary pollutant. What happens is ozone is produced when oxides of nitrogen and volatile organic compounds react with each other in the presence of solar radiation and relatively high atmospheric temperature. Okay, so it's a combination of high atmospheric temperature, presence of sunlight, volatile organic compounds, and nitric oxides that makes the secondary pollutant ozone. And if you think about it, you can understand that in global warming or climate change could be a driving factor of increasing ozone concentrations in the low atmosphere. Ozone does have some greenhouse capacity, can trap heat radiation, infrared radiation, and results in greater temperature in the atmosphere. Um, and ozone, when present in the low atmosphere, can damage vegetation and also can damage human constructions like buildings. Um, how it damages vegetation is actually by damaging or interacting with the cell membranes, right? And damaging the cell membrane, and of course, then it leads to cell lysis, loses the cellular structure, and that loses the entire histological structure of plant material, and thereby, with great exposure, um, the vegetation structure can be severely damaged, impaired, with impaired primary productivity and vegetation growth in the presence of ozone. And also, with the same way, it can also damage animal tissues as well, particularly highly sensitive parts. And such as the respiratory system is well known to be impacted, as you see in that little pyramid-like image. The respiratory elements, or the tissues in the respiratory system is most susceptible to presence of ozone in the low atmosphere. And recent studies also shows that the immunity is also reduced in the presence of ozone. How this happens is really interesting. First, in the presence of ozone, the innate immune system of human body overreacts, right? So it first, at the first phase of ozone exposure, the macrophage count increases dramatically, and ultimately those macrophages starts overreacting uh, in two different ways. One, sometimes these macrophages could attack B cells and T cells, which are component of the cell-mediated immunity of human body. And without B and T cells, the specific immune responses cannot be elicited. So so it actually increases the chance of being infected by a virus or bacteria. And also, due to prolonged exposure to ozone, even in lower concentrations, sometimes certain macrophages can undergo self-destruction. And also, the primary immune responses in the presence of ozone also leads to greater degree of inflammations, particularly in the respiratory tract, which actually damages the respiratory epithelial and exposing the host for infections. Now to lead. Remember, lead is actually a metal, right? And everything else that we have been talking about, sulfur dioxide, carbon monoxide, nitrogen oxides, those are actual gaseous components. Now, lead is actually a metal that exists in the atmosphere as a pollutant. Um, Now, how does the atmosphere get metals? Well, it exists in fossil fuel. Um, Not as a contaminant but as an additive intentionally placed there to increase the fossil fuel combustion efficiency. Now, in the same way, lead is present as a contaminant in metal deposits and also in coal. Um, so when you're refining coal, when you're mining metals, you're mining other forms of geological deposits, and when you smelt them, um, it could release the contaminant lead to the atmosphere. And also burning municipal waste, right, which is actually one major way many cities get rid of their waste. They burn it, right, incinerate it. Now that process, that municipal waste could contain many lead containing compounds. When you're burning it, you're actually releasing that into the atmosphere, which could result in really catastrophic situations. um, um, Lead accounts for about 60% of all metal-based air pollutants. And in United States, it's in the history of the U.S. environmental management, banning addition of lead to gasoline is a great victory for the environmental scientists. And the adverse effects of lead poisoning or atmospheric lead poisoning, that is not the only way lead poisoning can happen, remember that. But it's a major way that lead poisoning can happen to the humans. The impacts of lead poisoning is mostly prevalent in the nervous system. um, and in fact, in the United States, right, the reduction in children's cognitive functions, intelligence has been ascribed um, to lead poisoning by inhalation of lead contaminated air. And including United States, about 50 nations in global scale has banned use and sale of lead containing fuel. Um, the symptoms at milder level due to lead poisoning could include uh, recurrent headaches, irritability, and reduced sensitivity of your sense organs. Irritability related to irritability, it could be the aggressive behavior and also sleeping discomforts, abdominal pain, loss of appetite, um, digestion irregularities, anemia, because lead poisoning can lead to premature destruction of red blood cells or body's inability to assimilate iron. And impacts of lead poisoning is quite prevalent and more destructive and damaging in children. Children, if they're exposed to lead, even in very low concentrations, for a longer period of time, even for a relatively, longer period of time, they could suffer from neurological damage, serious, irrecoverable neurological damage, damage to nerves, to brain, right? Loss of developmental skills, neurological developmental skills can be impaired. You could observe significant deviations from their regular behavior, attention deficiency, meaning it could impair their learning, educational abilities, um, loss of hearing, damage to kidneys, kidney dysfunction, renal dysfunction. Mentioned about the reduced IQ before, and also overall reduction in the body growth can happen due to lead poisoning. So, lead poisoning is one of the most dramatic, profound impacts of that we can talk about in terms of one of the major pollutants.